So a chocolate manufacturer wants to promote a particular brand of chocolate called Toby by maximizing the amount of chocolate in their new Toby bar. The Toby bar is in the shape of a triangular prism as shown below, where the triangle has base B and the height h centimeters and the length of the bar is L centimeters. Okay, so the base B, the height h, and the length L. The surface area of the Toby bar is 120 centimeters squared, and the triangle is an equilateral triangle where B is between 3 and 9. So the base of this bar is going to be between 3 and 9 centimeters. Okay, so what we can do is we can see that we need to show that L is equal to 240 minus the square root of 3 times B squared over 6B. Okay, so let's start with this. The surface area of the Toby bar is equal to 120 centimeters squared. Okay, that's what we know it has to be. We also know that the surface area of a triangular prism can be given by this. So it can be, it's the sum of the rectangular parts sum of the rectangular part plus the sum of the triangular parts. Okay, so now we need to work out what the sum of the rectangular parts is. So we can see what I mean by this is one sort of rectangle here. Hopefully you can see that this is an equilateral triangle, so these side lengths here are B. So you can see that we have 3, so for the rectangular part, we have 3 of them, so it's 3 times base times length, so 3 times B times L. Hopefully that's pretty straightforward. Okay, so that's for the surface area of the rectangular parts. Then we're going to have to add on the triangular parts. The triangular parts, well, first of all, we've got 2 of them. We've got the front and the back, so we know it's 2 times something. Okay, well, what is that something? Well, the area of a triangle is a half times the base. The base is B in this case, so we're just going to call it B, times the height. Okay, looking good so far. The issue is that we have a H here. You can hopefully see that's an issue because our relationship that we need to show is a relationship between L and B. There's no H involved. So we need to get this H in terms of L or B. Now, the most straightforward way to do it is to draw a little diagram to the side of our triangle. We know that these lengths here are all B, which means that this distance here, do a different color, this distance here is B on 2, because it's half the distance. This here is B, and this distance here is H, because that's the height of our triangle. Okay, now what we need to do is just apply Pythagoras. So if we apply Pythagoras, we know that Pythagoras says c squared equals a squared plus b squared. Okay, don't let this b squared throw you off. In this case, if we're applying Pythagoras, we know that the hypotenuse is b. So on the left-hand side, we have b squared is equal to, okay, a squared. Well, let's say a squared in this case is b on 2, all squared. Doesn't matter which order these are in. Plus, well, plus h squared, isn't it? If we rearrange this to get h on its own, I'm just going to put h squared on the left-hand side. So if h squared is on its own, that means we've subtracted b on 2 all squared from both sides. So it's b squared minus, well, if we expand the squared in, it's b squared on 4. Okay, let's keep going. So h squared is equal to, well, this would be, let's write it out, 4b squared on 4 minus b squared on 4. So we have h squared is equal to 3b squared on 4, which means h is equal to the square root of all that. Remember, if we're taking the square root of the whole square root of a fraction, it's the square root of the top divided by the square root of the bottom. So the square root of the top is the square root of 3b squared. So that's just the square root of b. So the square root of 3b squared is square root of 3 times b. Divided by square root of 4 is 2. So we know that h is equal to the square root of 3b on 2. So we're going to use that information over here. So it's 2 times 1/2 times b times root 3b on h. Sorry, root 3b on 2. Because this is our h value. We've just worked out that this value here is our h value. Okay, simplifying this down a bit, 1/2 goes with the half there. Sorry, the 2 at the front goes with the half because we've got two triangles. We're multiplying it by 2. Okay, so then we've got, this leaves us with root 3b squared. Root 3b squared on 2. Good. And now all we need to do is add them together. And remember this piece of information here, that the total surface area is 120 centimeters squared. So if we do that, we know that the total surface area is 120 centimeters squared on the left-hand side, is equal to the rectangular part, which is 3bl, plus the triangular part, which is the square root of 3b squared on 2. Okay, now we need to rearrange this for L, because we want L on its own. Okay, if we can try that, what we'll get is, well, let's subtract this from both sides. So that will give us 120 minus the square root of 3b squared on 2 is equal to 3bl. Alright, let's put this on 2, so that'll be 240 minus, no, let's do it super clearly, 240 on 2 to get common denominators. What is the square root of 3b squared on 2, that's a b, equals 3bl. So that gives us 240 minus square root of 3b squared all over 2 is equal to 3bl. Squeeze it in here. Alright, now we need to divide everything by 3b. So it's 240 minus the square root of 3b squared on 2. Dividing by 3b is the same thing as multiplying by 1 on 3b. It's equal to L. So I'm doing a lot of steps here. Hopefully you can see what I'm getting at. On 6b is equal to L. Now, does that match what we have? I think it's slightly off. Oh no, that's right. There you go. So this here, you've just shown that L, so when the surface area of the whole thing is equal to 120 centimeters squared, the length is related to the base in this fashion. Hence, show that the volume V in centimeters cubed of the chocolate bar in terms of B is given by this. Okay, we should know that the volume of any prism is equal to the area of the base times the height. So the area of the base is equal to 1/2 times base times height. Well, height in this case we worked out is the square root of 3b on 2. 1/2 times base times height. Good. Alright, so the volume, well, we know that the volume of any prism is equal to the area of the base, which is this, times the height. So if we simplify this, we can see that it's equal to the square root of 3b squared on 4, and we need to multiply that by the length. So the length in this case we worked out in the previous question in terms of b. So we could just multiply by L, but we need the whole thing in terms of b. So we have to multiply by 240 minus the square root of 3b squared. 240 minus square root of 3b squared. All divided by 6b. Alright, test out your arithmetic here a little bit. So in the denominator we're going to have, in the denominator we're going to have, oh man, trying to draw a straight line. In the denominator we're going to have 24b. Alright, in the numerator we're going to have, if we expand root 3b squared into each term here, it's going to be 240 root 3 b squared minus, alright, root 3 times minus root 3 is minus 3. So it's minus 3b, or b squared times b squared is b to the power of 4. So that's what you get there if we move up here. Alright, what can we take out as a factor here? What goes into all in the numerator? What goes into all of these things? There's definitely a b squared at least in both of the terms, and there's also a 3. 240 is divisible by 3. The way you can check that is you add up the numbers. So 2 plus 4 plus 0 is 6. Is 6 divisible by 3? Yes. Then 240 is divisible by 3. So, and we know that's obviously 80. So we're going to take out 3b squared as a factor. We're going to be left with 80. Root 3 is still there. Minus, if you're taking 3b squared out of 3b to the 4, you're left with minus b squared. We're dividing that all by 24b. V equals, you've got to have all the equals v in there. V equals, so v finally is equal to, well, the 3 cancels with the 24, and the b squared, well, it's no longer squared on top. It cancels with that. So you're left with b times 80 root 3 minus b squared all over, well, 3 divided by 24 is 1/8, so we're left with an 8 on the bottom. So the next part says, sketch the graph of v against b on the set of axes below. Give the coordinates of the endpoints and turning point. Correct to 2 decimal places. Alright, so along here, I've just done this on Desmos. Along here, we've got the volume in centimeters cubed, and along here, we've got the base in centimeters. Alright, play around with your calculator a little bit. The scale will be a little bit off. You're going to have to work out that the scale, well, first of all, you know that your b values must go between 3 and 9, so you know roughly the scale that you're interested in for your b values, and then you just have to scale it right so that you can get a good scale for your volume values. Alright, give the coordinates of the endpoints and the turning point correct to 2 decimal places. Desmos has done it to 3. Let's done this one to 3 anyway, and this one. But you get the idea. These should be your answers here somewhere. So what it's saying is when the base length is 3, the volume of the Toby bar is 48.587 centimeters cubed. This point here tells us that when we have a base value of 6.796, we have a maximum volume for our Toby bar, which might be an interesting point to know if you're making these sorts of things. Use calculus to show that b equals 4 root 5 on the 4th root of 3 when the volume is a maximum. Hence find the other dimensions h and l of the chocolate bar that give maximum volume. Well, we know that v as a function of b is equal to b times 80 root 3 minus b squared, all divided by 8. Okay, show when the volume is a maximum. So we need to know the value of b when the volume is a maximum. Well, it's a maximum at the turning point. So we can say v dash of b, excuse me, you said that v dash of b is equal to, chuck it in your calculator, you get 10 root 3 minus 3b squared on 8. Okay, and what we're going to do is we're going to set that equal to 0 to find a maximum. We're finding a maximum because at the turning point, at the maximum point, the gradient is equal to 0. So we can use this differentiation to find out the value of b. Solving for the value of b gives us, we'll subtract 10 root 3 from both sides. So if it's minus 3b squared on 8 equals minus 10 root 3. Okay, you can see that the minuses will just go away. So let's get rid of them. The minuses will go away like that. Good. All right, so then we're going to multiply both sides by 8. B squared is equal to 80 root 3 on 3. And then we have to take the square root of both sides. So we take the square root of both sides of b equals, all right, let's write root 3 as an index. So let's write it like this. So it's the square root of 80 times 3 to the power of 1/2. The reason we're doing that is it just makes it mean that we don't have the square root over under a square root divided by the square root of 3. All right. What happens here? Well, remember, if you have anything multiplied underneath a square root sign, you can just take them two separately, give them both their own surd. So it's the square root of 80 times the square root of 3 to the power of 1/2. Well, that's just this times 3 to the power of 1/2 to the power of 1/2. All divided by 3 to the power of 1/2. This is where our index laws come in very handy. So we get b is equal to the square root of 80, all right, times 3 to the power of 1/4 divided by 3 to the power of 1/2. All right, I'm going to be really explicit here, and I'm going to say that you can take the root 80 out the front, can't you? Because you're just multiplying that into the numerator, so the root 80 can come out the front. And the reason I'm doing this is because then I just want to show that we've got 3 to the power of 1/4 divided by 3 to the power of 1/2. 1/2 even. Alright. So we've got root 80 times, alright, 3 to the power of 1/4 divided by 3 to the power of 1/2. What's 1/4 minus 1/2? 1/4 minus 1/2 is minus 1/2. Minus 1/4, sorry. So we'd get 3 to the power of minus 1/4. Alright, I'm doing loads of steps here, but you need to be able to get good at this sort of stuff. Well, that's the same thing as 1 on 3 to the power of positive 1/4. Remember, the negative makes it the reciprocal, so it's 1 over 3 to the power of positive 1/4. So it's the square root of 80. All divided by, if we multiply the 80 back into the numerator, the 4th root of 3. Now, that is also equal to, we haven't shown it yet, we need to show that root 80, so you can see it wants to show us that b equals 4 root 5 on the 4th root. 4 times root 5 divided by the 4th root of 3. So we've got the bottom part right, we just need to make sure the top part's right. The square root of 80 is the same thing as the square root of 16 times 5. And the clue and the question gives you that clue, because there's a root 5 there left over. So that's 4 root 5 over 4th root of 3, which is what you needed to show. So you can put a little square as required. Hence find the other dimensions h and l of the chocolate that will give maximum volume. Alright, so from before we know that h is equal to square root of 3 on 2 times b. Well, we now know that the base value that gives the maximum height is 4 times root 5 on 4 root 3. So it's root 3 on 2 times 4 root 5 on the 4th root of 3. Alright, let's see if we can simplify this down a little bit. So that's 4 times root 3 times root 5 if we multiply the numerators. And let's multiply the denominators as well. Oh, geez. Some seriously bad lines. So what we can also say is that it's 2 times the 4th root of 3. Alright, 2 and the 4 go. Well, they don't go. This 4 becomes a 2, and that 2 goes away. So that becomes a 2. Alright, now this is where our index laws again are handy. So it's 2, let's write it as fractional indices. So it's 3 to the power of a half times 5 to the power of a half divided by 3 to the power of 1/4. Alright, we can see that we've got the same base here. We've got 3 to the power of a half and 3 to the power of a quarter. That means, and they're divided by each other, so it's 3. So we subtract the indices, so it's a half minus a quarter. So that's 2 times 3. A half minus a quarter is a quarter, times 5 to the power of a half. Alright, now it's a bit neater to write it as square root sign, so it's 2. 3 to the power of 1/4, or remember, I sort of haven't spoken about this yet, but the denominator becomes the root, and the numerator becomes whatever the power is. So it's 3 to the power of 1 in here, but 3 to the power of 1 is just 1. And the same rule applies here. It's the square root of 5. There you go. So that's HL is even more annoying. It's L is equal to 240 from the previous question. I'm not pulling this out of thin air. L is equal to 240 root 3b squared on 6b. Now, this would seriously test your index law work, which is good, but I cannot be bothered. So I'm just going to say L is equal to what do we work it out to be? I would just say, let's just say this, you put that in your calculator where you say B is equal to 4 root 5 on the 4th root of 3. And let's quickly have a look. I have it. There is your answer there. Here. 4 root 5 on 3 to the power of 3/4 centimeters, which I forgot to write in my previous one. But yeah, I would be using a calculator for that. If you like, make sure you get an exact answer from your calculator. Don't just write an approximated answer, but then it's whatever that is in centimeters. What is the maximum amount of chocolate in centimeters cubed the manufacturer can put in the bar? Give your answer in the form C root D on e to the power of f, where c to e and f are real constants. Okay, hopefully the thinking behind this is not too hard, but the maths around it probably is pretty tricky. So we know that when the b equals 4 root 5 on the 4th root of 3, that we have a maximum volume for our bar. So all we need to do is substitute this b value into the volume equation. Now the volume equation is complicated as it is, and it says v is equal to b times 80 root 3 minus b squared all over 8. All right, and essentially what we're doing is we're just substituting in the b value. All right, substitute in this b. I'm going to take this b out of the numerator just to make things easier. So it's 4 root 5 on 4th root of 3 times, all right, it's 80 root 3 minus b squared. Well, b is again 4 root 5. That's a 5 on the 4th root of 3, all divided by 8, sorry, and that's minus b squared, so that's squared. All right, let's see how we go. This stays the same, 4 root 5 on 4th root of 3. All right, this part here gets messy, 480 root 3. All right, this thing's squared. Let's do it in a different color. This thing is what I'm talking about, squared. All right, what do we get? We get 4 root 5. Let's do the numerator first, times 4 root 5. All right, that is equal to 4 times 4 is 16. Root 5 times root 5 is 5, so it's 16 times 5. Looks like 16.5. 16 times 5 equals 80. All right, so we get 80 in the numerator. What about this? What about the denominator? 4 root 3. Sorry, the 4th root of 3 times the 4th root of 3 is equal to, well, that's 3 to the power of a quarter times 3 to the power of a quarter. We know from our index laws, if we have this sort of situation, the same base, and we can add the powers, so it's 3 to the power of a half, which is the square root of 3. Alright, so that makes this a little bit easier. So we say minus, well, we said the numerator is 80 over root 3, all divided by 8. Alright. Now, because I've looked ahead, I know that that doesn't want us to have a surd in the denominator, so we're going to have to rationalize the denominator. So we're going to have to rationalize this. We can't have an irrational number on the bottom. So if we rationalize the denominator, if you remember, it's 80 on root 3 times, you multiply the top and bottom by the value of the denominator. So it's 80 root 3 on 3. Good, so we're getting there slowly. So it's 4 root 5 on the 4th root of 3 times 80 root 3 minus 80 root 3 on 3, all divided by 8. Alright, let's keep going. Alright, we need to make common denominators in the numerator here. So we're going to have fractions on fractions, so that's not too bad. 4 root 5 on the 4th root of 3. Alright, we want this to have a denominator, we want this 80 root 3 to have a denominator of 3. So we need to multiply 80 by 3, so it's 240 root 3 on 3 minus 80 root 3 on 3 divided by 8. Alright, and because I'm running, oh no, we'll keep going. 4 root 5 on the 4th root of 3. Alright, 240 root 3 minus 80 root 3 is 160 root 3. Root 60 root 3 divided by 3, and all of that is divided by 8. Move over here. 4 root 5. Well, sorry, yeah, so it's 4 root 5 on the 4th root of 3 times, alright, 160 root 3 on, alright, dividing by, so the whole thing is divided by 8, so that's the same thing as multiplying by 1/8. And multiplying by 1/8 just means you're multiplying the denominator by 8, so it's on 24. We're almost getting there. We might need 2 more lines maybe, and then what we're going to say is, well, it's 4 root 5 on the 4th root of 3 times, all right, 160. What goes into 160 and 24? Well, 8 goes into both of those. 8 goes into 116 twice, so it goes into 160 20 times. 20 root 3 on 3. We're almost there, but we're almost also out of space. What I'll do... Alright, so let's squeeze this in. So from here, you can say that you've got 80. If you multiply the 4 in here, you get 80 root 5 times root 3 over... Alright, now you multiply the denominators. So we multiplied the numerators there. Now we need to multiply the denominators. So the denominator here is the 4th root of 3, which is 3 to the power of 1/4. And then this is 3 to the power of 1. So it's 1/4 plus 1 is 3 to the power of 5 on 4. Good, you can see in the numerator, I'll write this slightly differently. So there's a lot of swapping between square roots and indices, which can be confusing, but just remember they're completely the same thing. You get 3 to the power of 1/4. Oops, it was the square root, so it's 3 to the power of a half. Alright, and then you can see we're almost there, so it's 80 root 5 divided by, well, we've got the same base, 3 to the power of 5 on 4 on the bottom, 3 to the power of a half on top. So remember, if we're dividing the same base with different powers, we subtract the powers. So it's a half minus 5 on 4. Well, that would be, well, let's put this, a half with 4 as a denominator is 2/4. So it's 2 minus 5 is minus 3 on 4. So it's 3, since it's minus, it's in the denominator, but it's positive. So it's 3 to the power of 3/4. And there you go. You get your values for A, B, C, and D there. C is 80, D is 5, E is 3, and F is 3/4.